The launch and subsequent operation of the James Webb Space Telescope is one of the most exciting scientific events in decades. Although it has only been in operation for 1 year, it has given mankind a new and important understanding of the universe. The optical equipment carried by Webb telescope is far beyond any other equipment that astronomers have obtained so far. Its clarity and sensitivity are far beyond what we have seen before. The successful operation of the Webb Space Telescope has been hailed as the greatest scientific breakthrough of 2022. Webb launched a year ago on Christmas Day, 2021, and in the months that followed, numerous steps in the deployment of the telescope proceeded smoothly. In mid-July of this year, Webb posted the stunning first images. Webb's infrared telescopes and instruments will help us observe nearly every part of the universe in greater detail, including the most distant galaxies, giving us a glimpse into the past. The Pillars of Creation is a small region within the vast Eagle Nebula, which lies 6,500 light-years away. Dust, viewed by Webb's mid-infrared instrument, makes up the spire-like pillars that extend from the bottom left to the top right. Dust is a major ingredient of star formation. The red dots against the smoky backdrop of the dust and gas pillars, each many times larger than our solar system, are stars being born. For the first time, Webb telescope captured a direct image of a planet outside our solar system. The Exoplanet is a gas giant, called HIP 65426b. The images were captured using 4 distinct light filters. Purple and blue show the near-infrared views, while yellow and red show the mid-infrared light views. These images look different because of the ways that the different Webb instruments capture light. The small white star in each image marks the location of the host star HIP 65426. The Phantom Galaxy, also known as Messier 74, is a spiral-armed galaxy located around 32 million light-years from Earth. Images of the galaxy captured by James Webb Telescope is the most detailed look at this beautiful galaxy we have ever been given. The project wants to understand better how stars form. This combined image, in the middle, of the Phantom Galaxy uses optical data from Hubble and mid-infrared data from Webb Telescope. Red colors indicate dust. Young stars are in blue, and older stars near the center are in cyan and green. Pink indicates areas of star formation. Our Sun is 1.3 million times Earth's volume and 330,000 times Earth's mass. Our Sun is 5,500 degrees Celsius at its surface. But, for the real stellar heavyweights or Wolf-Rayet stars, our Sun is relatively puny. Wolf-Rayet 140 stars, or WR140, are gravitationally bound binary stars. Nearly the end of their lives, will burn through their core fuel quickly. It is already having released much of their hydrogen into space, is surrounded by curved yet oddly boxy rings that are red-colored in the image. The strangely shaped rings are caused by the interaction between WR140 and its smaller companion star. The stars are surrounded by a cloud of dust that is sculpted into that shape by its companion star. The Webb telescope has captured 2 of the most distant galaxies ever observed, the orange-red objects. The galaxy on the right is dated to about 350 million years after the Big Bang, which occurred 13.8 billion years ago, when the universe was only 350 million years old, about 2% of its current age. If initial estimates are correct, light from these objects has traveled such great distances that they appear as they did just 350 million to 450 million years after the Big Bang. This Webb image taken using near-infrared camera is showing the distant galaxies on the outer regions of the giant galaxy cluster Abell 2744. These identified most distant galaxies appear small and bright, suggesting that they are compact, disc-shaped objects rather than being diffuse and straggly. Their tidiness and brightness hint that early galaxies had already developed well-organized structures out of many stars, rather than being distorted and faint, as earlier studies with the Hubble Space Telescope had indicated. Thanks to Webb Telescope, a planet orbiting a star in the constellation Virgo is now the most explored world outside our solar system. When WST-39b transits in front of its host star, its atmosphere will absorb the host star lights. Because different gases absorb different combinations of colors, researchers can analyze small differences in brightness of the transmitted light across a spectrum of wavelengths to determine exactly what an atmosphere is made of. A transmission spectrum reveals the first clear evidence for an exoplanet's atmosphere of sulfur dioxide. Other compounds detected in WST-39b atmosphere include water, methane, carbon dioxide, sodium, and potassium, among others. Webb Telescope has also taken some time to check out the ongoings in our own backyard. It goes cloud gazing on Saturn's moon Titan. When the James Webb Telescope images came in on the morning of November 5th, scientists quickly identified the presence of two large clouds in the upper half of the picture of Titan. Those clouds confirmed a previous hypothesis that clouds should form in the mid-northern hemisphere during Titan's late summer. Is weather happening on another world? These images mark an exciting moment in the study of weather on other alien worlds. NASA may someday plans a Dragonfly mission, which will send a probe to fly around on Titan looking for life. The Southern Ring Nebula, also known as NGC 3132, located some 2,000 light-years away from Earth in the constellation Vela. This nebula could offer clues to how our own Sun may evolve in the future. The Southern Ring Nebula is a so-called planetary nebula and is the product of the implosion of a red giant star. When a star somewhat bigger than the Sun runs out of hydrogen fuel in its core, it swells into a red giant, which can be hundreds of times wider than the original star. Eventually the red giant sheds its outer layers, which then form the nebula, and contracts into cooling remnants called a white dwarf. Webb Telescope provided a more complex view of the nebula with its sophisticated equipment, the near-infrared camera, which sees warmer objects such as stars, and the mid-infrared instrument, which is a champion at spotting dust. Instead of the one large and one tiny star known from Hubble's view, two stars of equal sizes emerged by Webb Telescope. With the mid-infrared instrument, researchers saw that the white dwarf wasn't invisible, but glowing red unexpectedly, surrounded by a haze of cool gas. So, where had the gas come from? The only plausible conclusion, DeMarco said, was that another, invisible small star was orbiting the white dwarf much closer in, releasing the dust. The system of two stars suddenly became a system of three. Then, what could have caused the ripple-like shells? Brown dwarfs fall between planets and stars in terms of mass. They are bigger than a planet, but too small to be a proper star. Brown dwarfs usually give off a dim, reddish glow, a product of the modified form of fusion that happens on objects that are very massive, but too small to fuse hydrogen. The James Webb Space Telescope has directly detected clouds of sand in the atmosphere of one of the star-planet hybrid brown dwarf. These thick clouds aren't made of water vapor like Earth's clouds. Instead, they're composed of tiny particles of silicate. Scientists had hypothesized the existence of sand clouds for exoplanets. But Webb's new observations are the first verified discovery. The sand clouds are composed of silicate mineral particles. Those particles are most likely forsterite, enstatite, or quartz. Silicates can form in some brown dwarf objects, including the two middle examples in this illustration. The brown dwarfs are shown here ranging from left hottest to right coldest, suggesting sandy conditions occur in median temperature conditions. WST 96b is a hot gas giant exoplanet that orbits a Sun-like star roughly 1,150 light-years away, in the constellation Phoenix. A light curve from Webb's near-infrared imager and slitless spectrograph shows the change in brightness of light from the WST 96 star system over time as the planet transits its star. A transit occurs when an orbiting planet moves between the star and the telescope, blocking some of the light from the star. A spectrograph spreads the received light out into hundreds of individual wavelengths. Each of the 280 points on the graph represents the combined brightness of thousands of wavelengths of infrared light. The spectrum detected signs of hazy skies, clouds, and water vapor on the planet. This is strange. It was hypothesized by scientists previously that the planet didn't have any clouds at all, because the planet atmosphere has a strong sodium signature. The results are so contradictory, so that scientists are reanalyzing the Webb and previous data, trying to figure out how to reconcile the seemingly opposite conclusions. JWST is a galaxy pair in the Cetus constellation, situated close to the celestial equator. This image from the James Webb Space Telescope depicts the two galaxies in IC 1623 are plunging headlong into one another, in a process known as a galaxy merger. Their collision has ignited a frenzied spate of star formation known as a starburst, creating new stars at a rate more than 20 times than in our own galaxy. This interacting galaxy system is particularly bright at infrared wavelengths, making it a perfect proving ground for Webb's ability to study luminous galaxies. The merger of these two galaxies has long been of interest to astronomers, and has previously been imaged by Hubble and by other space telescopes. The ongoing, extreme starburst causes intense infrared emission. A thick band of dust has blocked these valuable insights from the view of telescopes like Hubble. However, Webb's infrared sensitivity and its impressive resolution at those wavelengths allows it to see past the dust and has resulted in the spectacular image of a combination of the mid-infrared and the near-infrared imagery. Merging of the galaxies may well be in the process of forming a supermassive black hole.